this video we're gonna do infinitely many limits. Just kidding. We're gonna look over a concept called infinite limits, but sometimes textbooks will label this section called infinite limits as simply limits equaling infinity. I like to, refer to this second method over here, limits equaling infinity, because it's more clear. I can intuitively guess what I'm gonna do in this section. So basically, what it's trying to say is, let's say I have a limit as x approaches some number a in its domain, either from the positive side or left hand side, or from both sides. Okay, let's just say positive to start it off, and I have some function f of x. Then, if basically, if this is equal to positive infinity, or it approaches negative infinity, this is basically it. It's limit equaling infinity. But what is the meaning of this? What does it tell me? Well, if your limit equals infinity or approaches infinity, because nothing can really equal infinity, it's not doesn't have that meaning. So let's say if the limit if the limit approaches infinity, approaches positive or negative infinity, okay? So if the limit approaches positive or negative infinity, then at that point x equals a, then at x equals a, you have a vertical asymptote, okay? You have a vertical asymptote. So I hope you already know what a vertical asymptote is. If not, then probably Google it at this moment. But basically, let's say I have a function, say y equals something, y equals f of x, and it's some weird function, just keeps on going like this, and then shoots up, and then you know goes like this, and then smooths out like this. And then let's say this is a point x equals a, and this is my x coordinate. So I mean, I don't really know any function that behaves in this manner, like goes squiggly like this, and then approaches a, and then smooths out. But it doesn't matter. It's just like a made-up function. It'll help you get the idea. So let's say if I have something like, what is limit as x approaches a from the positive side? Well, I just approach it from the right hand side. These will be my arrows. I keep on going up, and then it has no bound. I can keep on going as close to a, but not exactly to a as possible. But the closer I get to a, the further I go up and up and up. So basically, it's equal to infinity. It's not equal to infinity. I shouldn't say that. It approaches infinity. Okay. Now, uh, since this is the case, let's also look at the left hand side. So let's say limit as x approaches a from the negative side. What's the case now? Well, I can approach it from the left hand side. I'll have my arrows. The closer I get to a from the left, okay, the farther up I go. The y value gets bigger and bigger. So this is also equal to infinity. And since limit as x approaches a from the positive side and the negative side are the same thing, same value, infinity is equal to infinity, then we say that limit as x approaches a, just a, not from the positive or the negative, of f of x is equal to infinity. And we say that this function f of x has a vertical asymptote, so vertical asymptote BA at the point x equals a. Okay. Now, if you want a concrete example, this function I can almost guarantee will show up in most textbooks in calculus. Okay, it's either gonna be y is equal to 1 over x or y is equal to 1 over x squared. So one of these two functions, like I'm just gonna do it in the next slide so I get more room to do it. But one of these functions are almost guaranteed to appear in textbooks where they first introduce you to limits. So let's say I have a limit as x approaches 0 of 1 over x. So what it seems impossible, right? So 1 over 0 is infinity. But let's draw it out. You'll get a better idea. So this is x, and this is y. The graph of 1 over x is something that you should probably just know. Okay, it looks like this. On the first quadrant, I have this, and on the opposite quadrant, the third quadrant, it looks something like this. So in order to figure out x approaches 0, just not positive or negative, I need to figure out the two one-sided limits I have. So what is a limit as x approaches 0 from the negative side? So I approach this from the left-hand side, and I keep on going. The closer I get to 0, the further down I get. So limit as x approaches 0 from the negative side is equal to negative infinity. The closer I get to 0, the further below the x-axis I get. Similarly, what is the limit as x approaches 0 from the positive side? Okay, the closer I get to x, or which is 0, from the right-hand side, the further above the x-axis I get. So this is equal to positive infinity. Okay, so clearly the limit itself does not exist because I get two different values, negative infinity and positive infinity, if I'm approaching it from the left-hand side and the right-hand side respectively. So the limit itself does not exist. But we say that at x equals 0, there is a vertical asymptote for the function for the function 1 over x. Okay, now what happens, let's change it up a little bit. Let's say I have something similar. Let's say limit as x approaches 0 of 1 over x squared. Does the limit exist? If it does, then what is it? If not, then what's the interpretation? So limit as x approaches 1 squared is somewhat simpler to visualize. It'll look something like this in the first quadrant, and then it'll look something like this in the second quadrant. And since it's squared, all the values are greater than 0 or equal to 0. Basically, it never equals 0 because 1 over 0 doesn't equal anything. So let's say limit as x approaches 1 over x squared. From the positive side, what's the value? Well, if I approach it from the positive side, I can keep on going, but I'll get infinity. Then I can do, similarly, I can do limit as x approaches 0 from the negative side of 1 over x squared. And similarly, I approach it from the left-hand side. I think you get the hang of it by now, how to do one-sided limits. And I also get positive infinity. So in this case, does a limit exist? Yeah, because the limit from the positive side and the negative side of the same value 0 is equal to each other. In this case, they're both equal to infinity. So a limit exists and it's infinity. But every time the limit is equal to infinity at some point a, whether it be equaling from the left-hand side or the right-hand side, we say that there is a vertical asymptote at the point x equals 0. Okay, so basically, I'm just going to do one more quick intuitive thing over here. If I have any function, this is x, this is y, I have any function, goes like this, shoots up at the line x equals a. Okay, if the limit, in this case, let's say this is f of x, so if this is f of x, then I have that limit as x approaches a from the negative side, the left hand side of f of x is equal to infinity. Okay, now I'm just going to state it. I'm not going to write 6 different rules for it, but I'm just going to say it verbally and you'll get the idea intuitively. If the limit from the left is equal to positive or negative infinity, or if the limit from the right hand side is equal to positive or negative infinity, or if the limit from just, both the positive and the negative side is equal to positive or negative infinity, then we say that there is a vertical asymptote at that point x equals a. Okay, so I'm just going to say limit as x approaches a from the negative side of f of x is equal to plus or minus infinity, or limit as x approaches a from the positive side of f of x is equal to plus or minus infinity, or just simply, if both of these are equal to each other, then I have that by default limit as x approaches a of f of x is equal to positive or negative infinity if one of these six conditions holds true. Okay, then I say that there's a vertical asymptote. There's a vertical asymptote at the point x equals a. Okay, now we did vertical asymptotes here, which is basically limits equaling infinity. We'll later figure out how to find horizontal asymptotes, and that's basically, limits approaching infinity. But that's for later on. We're gonna go over some rules to help us figure out limits easily next time around. So I'll see you then, and I hope you gained a lot of insight about vertical asymptotes and how to figure out limits from both the one-sided and limits equaling to something at point x equals a. So I'll see you in the next video. Good luck. Take care.